Yeah, like Scott said, this is kind of a project I've been working on during the long winter nights when it's not enough light to go out and ski. So you got to do something when it's dark. To start out, I guess GIS maybe is unknown to some of you guys, maybe known to some of you guys, but it's real simple sort of concept. Essentially, it's a myriad of different programs that folks use to record and analyze data in space, and there's kind of all sorts of different things that you can do with that, and we'll talk about one or two of those now. Start out by giving you a paraphrase of a quote from a guy who's only my second favorite, Donald Rumsfeld. He said, there are things we know that we know, things we know that we don't know, and things that we don't know that we don't know. And for our purposes, the things that we know are observations. Observations that we get from you guys frequently about what the snow's doing in a point. Things that we don't know are the holes between our observations, and then the things we don't know are kind of the things we discover along the way when you start asking questions and looking into things. So I got like Scotty said, I spent a lot of time working in the field as a geologist, wandering around and banging on rock outcrops and collecting samples, looking for gold and copper and silver and all sorts of different things. And in the process, came across using GIS software for a number of different reasons, but mostly for trying to, as you're mapping out a given rock outcrop, or you're sampling this to see how much gold is in it or where the gold is in it, you need to keep track of that information. Otherwise, it's not really worth a whole lot to the folks that are paying you along the way. So for the whole basis of this is basically observations, and that's the backbone of any forecast, which is what we do at the Avalanche Center. And one of the kind of the two different types of observations. We have direct observations and indirect observations. For direct, this is kind of your classic pits and snowpack tests where you're digging in the snow, whacking on your shovel, measuring depth, looking at layers, looking at different grain types, different crystal types. You've got avalanche observations. It's another direct observation. This is our dearly departed Matt Whelan standing next to a crown here. Looking at slab characteristics, weak layer characteristics, depth of the crown, width of the crown, aspect, etc. And then traveling through avalanche terrain is another great variety of direct observation. This is my brother up on Galena Peak last winter. Kind of walking around looking to see, in this picture, is the wind blowing? Is it moving any snow? It appears to be moving quite a bit. Did it snow recently? Where did it snow? How much did it snow? Are you building slabs? Mapping out weak layers as you go, future weak layers. Is there surface hoar, near surface facets? All those sorts of things. And then we have indirect observations. And kind of lay out two different types of indirect observations that we use for forecasting. The primary one is going to be remote weather stations. This is a little weather station in the center there. This is up in Highlight, actually, back by Bozeman. So these are inherently qualitative or quantitative, something you get numbers out of them, generally wind speed, wind direction, temperature, snow depth, SWE, etc. And another real useful indirect observation that we have around here is glassing. Again, Matt Whelan showing us how to glass, and you can just ignore that the tow mirrors are duct taped on the Suburban. I won't draw any attention to that. Exactly, yeah. Donate to the Avalanche Center. Oftentimes I like to, I generally don't carry binoculars, but I have a long lens on my camera, and oftentimes I like to go sit on top of a mountain and, do a 360 and spend an hour looking around at all sorts of different things, and it's amazing what you can see if you take the time to look. And then another way to break down observations by observational scales. We'll define 3 scales for you: micro, meso, and macro. The micro scale is kind of the snow pits, or looking at an avalanche crown, the in-your-face sort of observation. This is world-renowned forecaster Doug Chabot out of Bozeman showing us it's kind of a bit of a non-traditional method of looking at the snow. Not really sure what conclusion he's drawing here, but mesoscale observations are kind of what you might see during a day over the course of a tour. You start at low elevation, you walk through 3,000 feet of elevation, walk along 5 miles. You look at a bunch of different aspects. See some avalanches. You might see some animals. You can kind of check the temperature as you're going, often not necessarily measuring it, but those sorts of observations. And then macro scale observations, which are often larger scale than you can generally record within a day. And for forecasting, micro scale and mesoscale observations are pretty important. And then the macro scale is often not something you necessarily have reported to you, but that it's kind of the synoptic picture that you're trying to generate. Probably don't need to talk about where we are. I think everybody's still around, knows where we are, but obviously South Central Idaho there. Got our 4 zones, and then a little bit of a closer look at the 4 zones. I'm kind of going to be focusing on some of the obs from Smoky Boulder, because that's where we get the most obs from anybody, and it's kind of where the heaviest user traffic is. So we've kind of covered our known knowns. How about our known unknowns, the holes in between our observations? So what you might wonder is where you're getting observations from. And these are kind of mapped out. This is one of the products from the database that I generated. I've mapped out where we're seeing our observations from. Obviously, this is Ketchum, and then 75 running up and over Galena Pass. And the bigger the circles are, the more observations we get at those individual points. This is Titus Ridge here. We got 58 observations there. This is as of about 2 weeks ago. And what you can see is that there's definitely an inherently irregular distribution of observations. There's some pretty conspicuous blank areas in the map where we don't see a whole lot of observations from. So obviously looking across at the cross earlier this year, it's a bit more of a, not necessarily a quantitative way to see that the user traffic can be pretty heavy on the pass, but obviously it is. This is during the mid-December dry period when everyone was kind of fiending for snow. So what I did is I drew a buffer zone around these observations here in our Smoky Boulder zone. And around these pass observations, it's a one mile buffer to it's kind of a number out of the dark, but generally represents maybe what you might be able to look across to if you don't have a long lens or anything like that. And what we saw was that 56% of our observations for all of Smoky Boulder, which is about 190 observations as of 2 weeks ago, 190 out of the 350 obs came from that zone, from that kind of the little blue buffer. So we have 4% of the zone, about 18 square miles, were in the blue buffer, to forecast for about 400 square miles in the green zone, which obviously leaves you with a little bit of a problem, and it's something that you're aware of that when you're forecasting, and you kind of know driving around that that's where people go, because it's pretty easy to drive from Ketchum and not see anyone along here skiing anything in here, and not see anyone heading out north, but seeing about 30 or 40 cars through there. So irregular distribution of obs here primarily is a function of access due to the highway, and then we also have a kind of unique situation here. We have an extensive system of huts and yurts. This is looking at the Pioneers and the Pio yurts down in here, and so we have these clusters of observations around these individual points where people will go and spend a few days and then come out, and we'll get observations from the guides and that sort of thing, and then kind of big holes in between those. Another thing you think about when you're forecasting is what the motivation behind the obs that you might be getting are. For guides, primary motivation is probably client safety, though ski quality and access are pretty close seconds. Forecasters is relatively similar. Safety is primary concern for us when we're going out, and then stability assessment instead of ski quality and access are secondary. Ski quality is a close third if you can get all the above with and maintain that, but oftentimes you don't really have that choice. And for the public, it's sometimes hard to know what their motivations are. I think most of them, if you ask them, they might say that they go out hoping to have a safe day, but I think probably ski quality ranks pretty high up there for them. And the other thing that affects kind of the distribution of observations in this zone is where, or the type of observations is who we're getting them from. So if we go back to this map here with Smoky Boulder and the layout of observations, and then we'll put you can see you've got obviously pretty irregular distribution of obs up there. And as a forecast center, our job is to provide a forecast not for this little spot here, but for every area within our zone boundary. And so our goal is to hopefully have a bit more of a spread out distribution of observations so we can see what's going on across the area. So again, these are those observations, and then those blue circles are our observations. And hopefully that appears to be somewhat more regularly distributed, but obviously you've got this kind of wild card black hole here in the bottom quarter of the map, and that's essentially back to the question of access and how do you get back there. And the only people, or basically the only people who get back there, and the only reason we have any obs back here, because we have the heli ski guides who have a little bit easier transportation than the rest of us. So that's it's kind of one way I've thought of to use the database that I've generated. We've taken all the obs that we've seen in the area and these points are just for this season, but we have a table that goes back about 5 years that I've kind of been trying to accumulate all this data in and massage it into a usable format. There's a few things that we can do with it. We can record and analyze our known knowns. We can identify and strengthen the areas where we have known unknowns, the black holes in between, and then increase the awareness of the fact that there are things that we don't know that we don't know. And moving forward with this project, there's a few things I'd like to continue to do. I think incorporating snow pit data is pretty useful. We get a lot of snow pits from you guys, and finding a way to put those into point format so that you can kind of query the database for height of snow or depth of weak layers or that sort of thing. Similar idea for incorporating weather station data. One really important way that I think it could be used is to record historic activity, which is particularly interesting here where we have urban avalanche problems, but to see where you see avalanches under a given weather pattern and what sort of lead up you have to that, and then talk to some of the people who have that information in their head, and that's the only place that exists, because oftentimes there's folks who have spent decades around an area and they've seen things that nobody else has seen and hasn't been recorded anyway. And if you don't take the time to record that, it's essentially lost to history at a certain point. And then, in kind of the same sense, digitizing and analyzing active avalanche cycles. So we'll look at a couple photos from a cycle that we had at the end of March. A super brief weather history for this. We had a couple days of pre-calm weather leading up to this, clouds moving in and out, enough sun to cook on a crust, but not really bake things down. And then had about a 24-hour, maybe 28-hour period where we got a pretty good pulse of moisture and warm air coming in off the Pacific that tracked right up the Snake River Plain, and rain levels climbed through that storm up to about 90, at least 9,000 is what people recorded, but it's hard to know without being out there. And as a result of that, we saw a pretty impressive avalanche cycle. Some pretty neat wet slabs that we kind of talked about as an avalanche center. If maybe we're seeing some of this concentrated at that rain line, because at the end of that storm, it really ramped up and we were getting 2 tenths of water, 2.5 tenths of water in an hour for a couple hours right at the peak of the temperature. And when the skies cleared, we saw a lot of slabs that looked like that, fresh right at the end of the storm and right near the rain line. All these photos are looking up from the Eagle Lake Divide with that long lens on the camera, but some neat photos where you see just multiple sets of crowns everywhere you look, and a lot of this stuff is kind of that classic wet slab looking avalanche activity that we saw from near the end of the storm. More of the same looking south from there. This is looking more kind of westish, big deep slab crown over on Bear Peak. This is left fork of Placer with some pretty wild sled tracks up there that fortunately didn't result in a whole lot. And then again, more deep crowns here. So what I did is I looked through all these photos and digitized where we were seeing all these avalanches. And our little kind of the red marks on this map, if you can see them, it's kind of a bunch of them along here, a bunch here, and a bunch there, are all from that single storm. And I recorded, I think, 114 avalanches in that storm that I could see from pretty relatively limited amount of terrain. It's kind of going up to the pass. We saw a few in the Sawtooth, but didn't have a whole lot of visibility for looking around for them. And using GIS, tried to pull out where those were and compare that to what sort of kind of weather we had leading up to that. So this is a wind rose on the left, looking at the wind at Baldy, obviously blowing pretty hard out of the southeast. And then on the right, we've got a rose with avalanche distribution. And you can see, obviously, there's a pretty big, with a strong, consistent south winds. It's not super surprising to see a lot of avalanches on the northwest aspect, but also quite a few on the northerly aspects, even all the way around to northeast. Obviously, not a lot further south. And then looking at all the same avalanches, these are all observed avalanches from that cycle, 114 again. And then kind of cut those down to Wood River Valley avalanches, where we saw most of the activity. And looking at the box and whisker, you see there's a pretty, 50% of your data is in this box here, which is about what we were seeing as far as recorded rain line. So 8,500 feet to 9,000 feet, 9,100 feet, 50% of the observed avalanches fell in that range. So you can, recording that information, you can turn it into stuff like this and try to look at it and tease out what caused what, and was it wind loading aspects? Yeah. Was it concentration of activity at the rain line? Yeah, it was probably that too. And it's hard to exactly make a definitive statement as to what was most important, but it's one thing that you can use generating a database like this and have for the future to look at. So. Yeah, thanks to guys beside the Avalanche Center, Scotty and Ethan and Matt, rest his soul, and all you guys for sending in obs all the time. And yeah, that'll do it.